Hi everyone. Today we are going to talk about how to 3D-fy your website using React Fiber. So before we proceed, let me first talk about myself. So this is Alok, your friendly neighborhood full stack developer. And I love JavaScript. I code, I blog, I write ebooks and give talks whenever I get chance. So when I'm not coding, I'm mostly watching anime or jamming to music. Apart from that, I love cooking. And a fun fact about me that I once trekked to a mountain in slippers. Mostly people don't believe that when I say that. So I always carry a proof with me that I'm not lying. So let's move forward and let's talk about what are the things we are going to discuss today. So firstly, we'll see what are 3JS, React Fiber, WebGL, and after that we'll start coding. We'll set up everything. Then we'll create some 3D scenes. After that, we'll talk about environment and staging. Then we'll talk about models, and at the end we'll talk about deployment. So let's dive in. Firstly, an introduction to 3JS and React Fiber. So before that, let's talk about what is WebGL. So WebGL is basically a JavaScript API for rendering 2D and 3D graphics in any web browser. And it allows, it provides a low level access to the GPU, which enables us to render 3D graphics. And WebGL is the basis of libraries like 3JS. So as I said, 3JS is made on top of WebGL. So it abstracts the complexities from WebGL and it makes it easier to use those APIs. This includes graph, geometries, materials, textures, lighting, and etc. that we'll see later on. And it works in all modern web browsers. And 3JS has a good documentation and support network. So let me show you some examples so you will have a better idea of what I'm talking about. How 3JS can be used in live projects, what are the different things we can do. So let's first have a look at a website that NASA has created. So you can see here we have one solar system which we can interact with. You can zoom in and zoom out. You can also click on satellite and it will take you to that satellite and more clearer view. You can also interact with this satellite from all angles. So it is now you have a way to interact with the solar system, which makes it more easier and also more informative and also a cooler way. So also one more example that I can show you, which is a very basic one, that I created a portfolio of mine using React Fiber. It's not much, just a laptop which is waving through, and it has my resume in it, which you can scroll down and read. Also, you can interact with the laptop. Pretty much this much. So there are a lot of ways. So you might have gotten basic idea of what 3JS is, what we can achieve through it. You can use models like this laptop. You can add interactivity like this one. You can add animations, lighting, all other stuff. Let's move forward. Is React 3.5 or so basically when 3JS started gaining popularity, so the React ecosystem wanted to integrate it with the ease of component-based, we can say component-based way. So R3F combines that React's declarative syntax with 3JS 3D capabilities. It uses JSX and React hooks to manage 3D scenes. Now it allows us to make reusable components of 3D objects and logic. And the best part is that it can easily integrate with existing React projects. So before we proceed to code, let me first talk about what is Dre. So Dre is a community where people are creating helpers revolving around 3JS, which they have hosted, and you can easily just import those helpers and use it in your project. We'll be also using some of those helpers today. Let's start and set up everything. So for that, I'll be creating one Vite project and then we'll integrate React 3 Fiber in that. So to save time, I have already started set up one Vite project with React configuration and I have installed the packages. So if you have a look, we have 3 packages that I've installed. One is native 3JS that we need. Another one is React 3 Fiber. And the last one is that we'll be using for help. That's pretty much the packages we need. Rest the folder structure is similar as any other React project. We have our main JSX, then app.jsx. We'll talk about this code later on. I have also started our server and it is running in port 5173. Right now it's blank, so there is a blank screen. We'll start how the talk will go is we'll talk about topic, then I'll show you some code here and live you can see the effects of those code. So let's move forward. So before we code, let's talk about some of the basic components of 3D scene. So firstly, a scene, obviously. So a scene is something like a stage, right, where there are different objects, for example, actors, lighting, and everything. So a scene is something which will contain objects. Then we have an object, which is any object like cube or a model or your lighting or anything. Then we need a camera so that we can see that stage. So camera will be our point of view through which we'll be able to see the scene and the objects. And at the last, we need a renderer. So the use of renderer is to combine everything and with the render it with the viewpoint of that camera. So let's talk a bit in detail. So scene is basically, as I said, a container to contain 3D objects. And then a 3D object can be defined using two things. Firstly, a geometry. The geometry is basically the shape of that 3D object, whether it is like a sphere or a cube. And then the material is the look and feel of that object, which is like the appearance. What is the color? What is the texture of that material? And when we combine a geometry and a material, it will create a visible 3D object, which we call mesh. So let me show that with the help of an example, so you'll have a better idea. So right now here, right? So we have one scene, for example, this one, this whole sky color area, right? So this is a scene and there is a camera placed in front of that scene. So with that, the viewpoint of that camera, we are just watching at the front of this scene. And then we have a geometry right now here, which is a sphere geometry. And then we'll introduce our material to it. So you can see we have a white color material which has a smooth texture, which is reacting to a light source, which is somewhere around here. So you can see there's a light illuminating this area, and the area that is in the back side is like a bit darker. So this is now combining a geometry and a material. Right now, this ball is a object, or we can say a mesh. So this is the basic 3D example of what we can achieve using these four things. So let's move forward. Finally, let's start coding and create our own 3D scenes. But wait, before we write anything in React 3.5, I would like to show you how it would have been done in native 3.js. Basically, we have done it in like plain HTML file. So we'll see first how much code we need to create a small 3D scene in native 3.js, and then we'll compare it with how much code we need to actually replicate that in React 3.5. So let's proceed. So firstly, we need a simple HTML file where we'll have our body tag. There we'll add canvas, which is basically canvas is as the name sounds, it's like a empty paper where we'll draw our 3D scene. And then I have selected that canvas using document query selector, and I've stored it in a variable called canvas. Then we are adding one scene. Then we have our object. So basically we are, as I said, object combines geometry and material. So we have one 3-box geometry, and then the material is basic material. We'll talk about this in detail in the next few slides. And then combining those geometry and material, we are creating our mesh, and then we are adding our mesh to the scene. So next we need a camera. So there are different kinds of camera. So the perspective camera is similar to like our eye, which says the objects which are in far will look smaller and the objects which are nearer to us will look bigger. Then we are adding that camera to our scene. And at last, we have one renderer, which takes canvas as input. And then on that canvas, it render our scene with the viewpoint of camera. So this is the amount of code we need in order to create a small 3D scene. Let's see how this thing can be done in React 3.5. And yeah, that's it. That's all the code you need in order to replicate everything that we have seen in the past 3 slides. So let's talk about this one by one. So canvas is a component that will be importing from React 3.5. Canvas comes pre-built with camera, renderer, and everything. You don't need to specify it again or write it, add it to the scene. So it has scene, your camera, and renderer with some default settings. Obviously, you can customize if needed. Then we have our geometry. So torus knot is also geometry that we'll see. And then we have our mesh basic material. Once we wrap that around mesh, or we can wrap it with mesh, so mesh will automatically take this geometry and material, and it can serve as an object. We don't need to like manually bind it to mesh. So let's see using an example. So here in app.jsx, I have already imported canvas. You can see right from R3 fiber. And I have, for the sake of separation, I'll write rest of the 3D code in experience file, which is experience.jsx, and I'm importing that in our .jsx. Let's go to that file. Right now it's empty. So as I said, we need a mesh firstly. The rest of the things are already there. So I will add one geometry, for example, torus knot geometry, and then a material, which is right now we are going to use mesh basic material. You can see here we have our geometry, but right now we can't see it. Yeah, now you are able to see it. So we have one geometry, but it doesn't look 3D much. So let's talk about these things first, then we'll add few things in order to make it look more realistic and 3D one. So let me take you to the documentation of Three.js. So there are a lot of things like how to get started and everything. We'll talk about a few of things rest you can explore. So we have cameras, different kind of. So this canvas component has perspective camera by default. If needed, you can explore other types of camera and use it as per your need. Then we have our geometries. So there are different kind of geometries. So box geometry looks like something like this. Then we have capsule geometry, circle geometry, and similarly a different a lot of there. So what we have just right now use is this one, torus knot geometry. So right now we are watching it from just one side. So it's not looks 3D, rather just a plain 2D figure, but we'll soon make it more 3D one. So let's talk about lights. We'll see lights later on in detail. And then we have our materials. So there are a lot of materials like simple line basic material, or the mostly the one that we'll be using or you will be using later on is one is mesh basic material, which is this one, a material for drawing geometries in a simple shade, flat or wireframe way. Then other one that you will be using is standard material. So standard materials are those materials which basically react with the light. So when we'll be adding light in our project, standard materials are those materials which will react to that lighting. And we have one mesh normal materials, which is basically which material which shows the normal vectors to RGB colors. It's like maps them so that you'll have it kinds of look cool, but rather uses it for different purpose. For basically what we say, we need it for during testing purpose or well development phase. We need it to look into the vectors basically. So we'll be using these materials just for having a cool effect. So instead of mesh basic material, let's use normal material. See, now it's looking more 3D, right? So still right now we are not able to interact with it. And also still the camera is placed in front of it. So we're looking at the front of this object. So let's move forward and explore the rest of the things. So now we have a small basic 3D scene where we have a canvas and we have added one object which is torus knot geometry and with the normal material. So let's talk about access helper. It's basically a helper which kind of gives you a visual reference of all the three axes we have, which is X, Y, and G in our 3D scene. So let's add it in our project. And for that, you can simply just add access helper in your, simply import it and just use it. So there is our access helper. You might be able to see it is behind our object. So let me just comment it for some time. See, let me increase the size of our axis. And for that, it takes and prop called args, which will take the unit of how much you want to keep the size of that axis with. So I'm giving it 10 right now. So you can see the size increase. So this green one is our y-axis, red one is our x-axis, and G is our, which is of blue color. It is our GX. But right now you are not able to see that because, as I said, right now our camera is placed in just vertical of this one, just with the front of it. So the blue line that is coming as G-axis, it is like perpendicular to our camera. That's why like it is not visible right now. So we'll see that blue line just after this slide. So the next one is orbit control. So our orbit right now, as I said, our camera is static. For example, this one is our stage and our camera is just placed at the front of it. So our camera is static right now. So orbit controls give you that functionality that now you can move your camera from left to right or interact, zoom in or zoom out. Like you saw in the NASA website, right? Where we were able to like zoom in, zoom out. We can just playing with the scene. So let's add it to our project. And as I said, for to set up orbit controls, we need a lot of, but thanks to the people at Dre that they have created and bundled it. And you can simply just import it from Dre and use it. So I'm adding orbit controls in our project. So it's added. Now let's try to interact. Earlier, when I was trying to click on our scene or interact with it, it was not responding. But still, let's try now. Now you can see I can interact with our scene. So now you are able to, right now I'm just moved my camera from front to this side. So now you can see we have our Z axis, which is a blue color. Let's add our scene, our object back to our scene. You can just see that our objects start at the origin, right? So from there we can move it, which we'll see in the next slide. So now we have our orbit controls. For the next few slides or rest of the project, I'm just changing our material, basically geometry, sorry, to some other stuff, other shape, which is easier to visualize and see, which is for now box geometry, sorry. And instead of normal material, I'm using basic material. Here you can see, right, as the whole surface is plane, or we can say perpendicular. So it has the same color. But when it had a curved surface in torus knot geometry. So for each of the perpendicular lines, there were different colors. So it was imitating the base spectrum. But right now, as this whole surface is just a plane and all the perpendiculars are on the similar line. So it is of same color. So now we have our basic material. Let's talk about properties of how we can add color to our material. So simply you need to pass color prop and whatever the color you need. I'll go with medium purple. So right now we have our box object, which is placed at origin. If you can see, it is like at the center of our C. So now let's move forward and talk about transformations. So for transformations, we have basically three things. One is positioning, where like we can change the location of our object in our 3D scene. Right now it is at, you can see at the center. We can move it like in any of the axes. Also, we can rotate that object around it, any of the axes. And the last one is like scaling that object. Okay. So let's see these with the help of some examples. So in order to change that, we can simply pass then prop in our object, and which takes three parameters, x, y, z respectively. So let me try to move it on x-axis 1 unit, and I'll keep the rest as 0, 0 only. So now you just see that this box moved 1 unit on the x-axis. Similarly, you can make it -1 and it will go to the other side of negative x-axis. Similarly, you can add to other axis, and now you can see our object is like at equidistant from each of the axes, like 1 unit from z, 1 unit from x, and 1 unit from y. Okay. Similarly, a rotation. So just instead of position, you can pass rotation, and similarly it will take 3 parameters for x, y, and z. So let me add. So if you see from this side, so our x-axis is going that way. So I've added rotation of 1. So our object was like this one first, and it rotated on the x-axis one. So you can see the changes. Let me add it one by one, like incrementally you add one, and you'll see the effect. So 2, you can see it rotating, right? Similarly, I can rotate it backwards. So this is the way you can rotate or move your object in our 3D scene. The last one is scaling. So as we did with rotation and position, we need to pass scale prop, which will take one input, like how much you want to scale your object. For let's suppose consider right now we have 1 unit, so we can just make the size double, or we can make it half of our original. So that's how basically scale works. So these are the transformations of positioning, rotation, and scaling. Next one is animations. So animations, like we all know the basic definition, that series of pictures when shown together at like less interval of time, it looks like an animation. So that's the same thing here. We have a code which will execute on every frame render. So for example, our renderer is rendering some frames one by one, right? After some certain amount of time. So will have a code that will render on each frame, which will give us an impression of animation. And for that, we'll be using used frame hook, which will basically give access to each frame. And then we can animate any object using by changing the properties of transformations like position, rotation, and scale. So let's see them one by one. So as I said, first we will need use frame. So this one has two params. One is state and another one is delta. I'll talk about these one by one. Next, in order to now we have our frame. Let's talk about state first. So state basically contains the data about the scene, right? So let me console log it and check it. So if you see here, we have details about camera, clock, or you can mouse, pointer. So we have information about all the different things or objects in our scene that we can use to modify or customize it. Also, you can see right now it is this console.log is being rendered on each frame, right? You can see it's still being rendering one by one. After in each frame, it is being rendered, it will go on. So let me remove that. Or wait, let me talk about delta. So what is delta? Delta is basically, you can say, the time difference between the last frame that was rendered and the next frame that will be rendered. So let me console log that. So you can see, right? So this is the amount of times which is in second 0.016. So this is the amount of time that is the difference between, let's suppose if I take any two one. So this one was the frame rendered and the next one the frame was rendered. So 0.16 on average is the kind of like the difference between two frames, the time difference between two frames. Let me remove our console.log. So now we have a use frame hook which gives us access to each frame. But now we need to add some transformations in our object. For that, we'll be using reference. So we'll create one ref for our box, which we'll call box ref, and then we'll import use ref from React. Now we'll attach that to our object. So now our reference has been attached to our object. Now we have access to our reference, and it has one property called current, which has other properties. One is position. Then we can just target any axis. For example, I'm taking X. And what I'm going to do is that on each frame, I'm adding 1 unit to the X position of our object in the X axis. So let's try that. So you can see that right now our object just went in the X axis 1 unit. So let me just turn it this side, so you'll have a better idea. Let me refresh it and start our screen again. So it was too fast to see because 1 unit is too much for it. So let me reduce it to 0.01. Let me refresh our scene. So now you can see that our object is moving 0.01 unit on each frame, right? Similarly, so there is a thing like units, right? So there are different configurations. For example, 30 FPS or 60 FPS. So if we are going with units, then we'll have a different experience in this system. For example, let's suppose we have a 30 fps screen, and I'm adding 1 unit to our object on each frame, right? So after, we can say 30 frames per second. So after 1 second, our object will be 30 units ahead of its original position. And in 60 fps screen, what will happen is that after the end of 1 second, now as we are adding 1 unit and it has 60 frames per second, so it will be 60 units ahead of its original position. So the same animation will look different on different configurations. In order to give a similar experience in all the devices, we use delta. As I said, delta is the time difference between two frames, right? But if we're going to use delta, then even after 1 second, this object here the animation will not be that smooth in 30 fps, as like time difference is greater in 30 fps between frames than the time difference in 60 fps between the frame. So the animation in 60 fps will look a bit smooth as the time duration is less, so the object will go like but in 30 fps the animation will be not that smooth because the time difference is greater, so the object will move like. But at the end of the day, means at end of 1 second, the both objects will be at the same position. So now even after we have a different configuration, but the animation will look the same in different devices. So for that reason only, instead of going with plain units, we'll be using delta for our animations. So let me do it. So now you can see our object is going. Similarly, you can target any other axis while I refresh my scene, right? Similarly, instead of position, you can go with rotation, okay, or along x-axis, right? And similarly, you can also target scaling. So let me change. It's like scaling the object along x-axis and adding delta on each frame render. So now we have the Monkey King staff with us. So let's move. That's about animations, like how you can use frame hook to get access to each frame. Then using a reference, we attach to our mesh, which is basically our object. And then we modified our properties like rotation or position or scaling in order to create animation effect. So let's talk about environment and staging. So till now, we are only kind of playing with our object, not with the environment surrounding it. So instead of object, now let's play with our environment. So first, lighting. So lighting is to give more realism and depth to our 3D scenes. Till now, we just don't have any light in our, we can say, in our 3D scene. But still, we are able to see the object because, as I said, mesh basic material don't need lighting. Rather, mesh standard material needs lighting. So we'll see that. There are different types of light, ambient, directional, point, and spotlight, which we'll discuss in the next slide. Mostly we'll be using today ambient and directional light. Rest you can use and explore later. So there are different properties of lights that we can tweak with: color, intensity, position. And then when we add light to all 3D scene, it now gives us access to add shadows to it. As when there will be lights, there will be shadows. So we'll talk about shadows separately later on. So let's talk about different types of light. Firstly, we have one ambient light. So ambient light is like a general illumination that affects all objects equally, irrespective. Then we have directional light, which is like sunlight or indistant light. So directional light is, as the name suggests, it is somewhere as like sun, and it is directing its light to our object. Then we have point light, which is, as said, similar to directional light but a bit different. So it emits light in all directions from a single point. And then we have a spotlight. So spotlight is similar to flashlight. So imagine keeping a flashlight in front of a wall. You will see a round light, and apart from those round circle, the rest area will be dark. So similar kind of effect you will get using spotlight. So let's see a few examples. So as I said, in order to, let me remove our animation now. Let me also remove our scale and rotation. So now we have our initial scene where we are with our access helper and our basic box object. So instead of basic material, let's switch to standard material which reacts to light, which needs basically light. So I just converted our object from a Miss basic material to Miss standard material. Now you can see our object is there, but even I have assigned a color of medium purple. It's in black color because it's not black, it's actually dark. So as it is dark, so we are not able to see the color of our object. Let's add lighting to our project. And for that, as I said, we can use ambient light. So now as I added light to our environment, 3D scene, you can see as the definition was ambient light illuminates our the whole scene irrespective from all sides. Right? So you can see now we can see all the sides of our object is illuminated. Let's see then directional light. Also you can play with intensity. So if I add intensity on suppose 4, you can see the intensity of the light is increased. So instead of ambient light, let's use directional light. So now you can see, as I said, the directional light is right now at the top, like a sun. So the top surface of our box object, it is now illuminated, but rest of the sides, it is like still in dark. That's why it's like black color. So let's move our object light position off. So now I'm keeping my light like equidistant at the positive side of our origin, which is 1 unit. So let's imagine our light is around here right now. Okay. So that's why the light is coming from this side. And you can see these 3 faces, they are like being illuminated because our light is somewhere around at front right now. So these 3 faces are illuminated, but the other 3 sides, which are away from the light, they are still in dark. So this is like how directional light works. So let's move forward and talk about shadows. So shadows, as lighting add more realism, shadows add more depth and realism to our 3D scenes by simulating like how the light interact with objects. Right now we have a object and we have a light, but we don't have any shadows or that things right now. So it also helps viewers to understand the position and scale of objects related to other object and environment. And also one thing to keep in mind that adding shadows is like more will take away some performance. So adding too much of shadows here and there, like in every object, will make your website a bit slower or laggy. So we'll have to keep in mind when adding shadows, which are the objects that actually need shadow in our whole 3D scene, or which are the things we can ignore. Okay, so let's add some shadow in our project. So for that, firstly, you will need to enable your canvas to have the functionality of shadow, and which is simply by just giving a prop of shadows. And now our canvas supports shadows. And next, so I'll be right now we have one object. We don't have anything in order to capture that shadow. So we need something like a ground below our object. So whenever we'll have a sunlight, so when there is object, it will cast its shadow to that ground. So let me add one plane just below our. Let me add it first, and I'll explain. Which is not much actually. We are just using it in a different way. So right now we have a ground like thing. Let me refresh it and just okay. So it is a like instead of box geometry, it is a plane geometry. Then we have mesh standard material which supports lighting, which is of green yellow color. Okay. And then I have rotated it along x-axis like perpendicular. Yeah, like it was firstly like this, and then I have rotated it for like this, and then I have scaled our plane, and I have just moved it at the minus y axis down a bit so that it is below our object. Okay, so now we have our plane. Okay, and our setup is ready to add some shadows. So it is simply all you need to do is that to tag which of the objects will cast a shadow and which is the object which will receive a shadow. So firstly, our light will cast a shadow. right? Then this box will cast a shadow. And lastly, our plane, that is the ground, that will receive that shadow. So that's all you need. Let's see. You can see here, right? We have our light here somewhere, 111. So it is like throwing a light in our object. And then that object is casting a shadow on the ground. But what if instead of a static box, we have a revolving or a moving object? So will that shadow will react to that moving object or will it be static? So let's see that. Let me add rotation. So you can see, right? So on each frame render, that shadow is again being rendered. So that is the reason because of which it eats away performance from your website. So there are different ways. Right now you can see the edges, right, of the shadow. It's a bit blurry. So there are different ways through which you can make your shadow sharper and or more blurry in order to save performance. So when you will be using shadows, so you'll have to take care of these things so that your website don't result into laggy one. Okay. So next let's talk about background. So till now we have our object, but the background is still dark, or we can say there is nothing there. So we can add background to it. So first one is like normal, any color that you need to add. So end of the day, canvas is also one tag, right? HTML tag. So you can simply add any background color to it. Let's suppose I'm adding sky blue. So you can see now we have our background color. Or you can add gradients or images or environment maps. So let me add one picture that I clicked on my last trip as an environment to our 3D scene. And let's see how that turns out. Let me first remove this background color and let me to add environment you simply need to, as I said, some very good helpful people in Tray have already created that for us. So you need to import that environment component from Tray. You need to label it as a background, and then it will take the file which you will be adding it as a background. So I have placed one file here in public, pic.jpg, which is basically a mountain picture that we'll be using as our background. So let me import that. Okay. So let me remove these things. We don't need anymore. Sorry. Okay. Let me remove our box too. And also our SSL portion. Let me just fix it. Okay. Somehow I messed up something. Clean access at least. So now we have our box and our background. So you can see right now it's a 360 view of that image, but that picture was not made in order to support 360. So you can see that edges are just trying to take a paper and fold it and make it like a cube. That's why like the edges are like this way. But that's work. You got the idea of how to use environment maps. You can easily download different environment maps from internet. Basically, under licenses are free. So yeah, that's how we add environment to our 3D scene. Now let's talk about models. So basically the 3D scenes that you will use in live projects, which will not be only like cubes and planes or any spheres or torus geometry, right? You need models, for example, images, or like we saw in the NASA one, there was a satellite. So that is a model that we'll be using instead of just simple cubes. So models can be created using different ways. One simple way is using a Blender software, using which we can create models for our 3D scenes, and then we can import it and use it. So there are different formats of models that are supported in Three.js. The most popular one is GLTF or GLB, and then we have one OBJ or FBX. So as I said, models can represent anything from like characters to vehicles or entire environments. So let's add a model in our scene to have a more better understanding. And for that, okay, we need to use a primitive component. Okay, so let me first remove the animation. And let's firstly import our model first. So I have already downloaded one model, which is along with the license and everything. So we have our scene.gltf here with us, which we'll be importing. And the rest, these are like the supporting files of that model. So for that, we'll be using useGLT. So let's suppose our model is here, which is again importing from Dre, and it will take the path to our model. So which is basically slash word slash c dot gltf. Now we have our model imported. Now let's add that to our C. And for that, as I said, we need a primitive component, okay, which will take object, which is our model dot scene. So now I have added that, but it is not visible right now. Okay. So let's see probably, yeah. So we have our model right now, but it is like too bigger to like accommodate in our scene. So let's scale it down. So as we already know about the properties that you can use, so scale is one of them using which we can modify the size of our model or any object. So I've tried with it with different numbers. Like when you will be starting to create or develop these scenes, you'll have to play around, use hick and trial method to get the correct size. Or another one is like you need to make your models in order to incorporate in your website. So you'll have to make it of that size that you need. Instead of then you won't have to modify it here. So I've tried with different units, and one that I could find is like 0.03. Okay, so now let's unit this box. Okay, so now we have a scene where we have an environment, a model, right? Now, can we do everything that we did with box with this model? And that is absolutely yes. So as we added a reference, we can add here. Let's name it as box ref. Okay. And similarly, we can access it like rest of the thing. Okay. So now you can see we have this word, which is like how we used animation in objects. Similarly, same thing we can do with this one too. Also, we can go with position. Now you can see our bird is flying in the sky. So this is the way we can create a small 3D scene where like it's more interactive way instead of just plain simple cubes and other objects. So let's talk about deployment. So I wanted to show you that now this don't look like a simple HTML static site, right? So we know the like normal ways to deploy any site using Netlify or Vercel or other stuff. So is it like a different process to deploy these kind of websites which are like have 3D assets and interactive and such stuff? And that is absolutely no. You can as simply you created or deployed other plain HTML static website, you will can do this one also. So just you need to create the build and you can deploy it as similar as like in Vercel or Netlify or GitHub pages. So as we all know in Git, we can create the build using npm run build. Already done that. So it will create one dest folder where you'll have all the assets and like index.html and every code like compiled and ready to be served. And then you can deploy this folder anywhere like internet. So I've already done that in Netlify. You can probably check it if it's still live. Wait for load. And yeah, so this is the same thing that we just created in our local, right? So I just created a dist folder and created a build and just deployed it in Netlify. And now you can just access it in your website. Just it's said 3.js hyphen dash talk dash demo.netlify.app. You can open it your system right now and can check it and see it. And this is just a kind of introduction to 3.js. There are a lot of things you can explore on yourself. And there are a lot of creative ways you can use it. And maybe let's suppose you have an existing React project of airlines, right? So you can add a small aeroplane, 3D aeroplane that is like flying around your website or in buttons, or let's suppose you have one hotel website. So you can add a small window, a small canvas, and place it at your website at the top corner, small window, from where a 3D safe model is coming on the window and waving. Sometimes it's coming with a different days or just saying hi. So there are a lot of creative ways you can think of. You can use 3JS in your website, either a new one or existing one. So that's it from my side. Thanks. Thank you again for being a wonderful audience. And I hope you have learned something from this talk. You can reach out to me on the Cool Learner, which is my Twitter handle. I'll be always love to interact with you and just talk. So thanks again. Bye bye.